recording can begin with vigor. Okay, so ladies and gentlemen, for those who have missed this part of the show, we've gone in and constructed a state chart here with susceptible. We have a message-based transition for infection. We have a timeout-based transition. And I'm going to ask you folks for the timeout-based transition to make it a mean so this is going to be incubation period in time. It's going to be 3 days for this incubation period, which is the same as the latent period. 3 days here. That's going to be the timeout. Then we have this contact rate, which is going to be occurring at a certain contact rate per day. Okay?
You have to put main dot?
I'm sorry? Yes, you have to put main dot. Thank you. Good call.
And for exposed, should you go messages.exposed?
Yeah, we should probably do that. I think it's going to understand. I haven't yet modified that, but yes, we should do messages.exposed. Messages.exposed. Now, for some reason, it doesn't autocomplete that, and I don't quite understand why. But this transition is on a particular message. It's a message transition if the message messages.cured is received. This one is a message transition if the particular message messages.exposed is received. Is that okay? Okay. Ladies and gentlemen, so we're much of the way through this now, and soon we'll be rising to the key point. Okay, weaving together our learning for the past day, how am I going to encode visually the fact that someone's in each of these states? So I want this one to be green, I want this one to be yellow, and I want this one to be red. How am I going to indicate this? A variable. So let's add in a variable called color. And what do we need to do for this guy here?
Get to go to get the line color from that other menu.
Sorry, get the, yes, that's true. We're going to need this one here for the man. It's not easy. We're gonna first do these colors here. So this one is color equals green, right? You've been through this before. This is kind of old hat for you now. Color equals yellow. But honestly, a lot of any logic is like this. You master the core things, and you're doing a lot of things repeatedly, so you can often remember it. It's harder if you only use it very rarely. But if you're using it fairly frequently, a lot of the stuff is very familiar. So I set this color variable. What sort of variable should this be, this color variable? It should be a what? It should be other, and of what other type? Color, with a capital C. Its initial value I'll make black without privileging that. This is color equals green, color equals yellow, color equals red. And then, just as Nick said, is it Nick? Yeah. For this one here, this person shape, we need to go up to, where do we find this person shape? Can anyone tell me?
Patient.
We go into patient, patient, presentation, person, right? Shape body, right? And then we have to go to fill color. What do we have to do? Yeah, we have to make it a dynamic value, and we have to say color, or I could say this dot color if I want to be particular, my color, okay? Again, it will fill that in automatically if you don't. Okay, great, ladies and gentlemen. You've built your, what, third infection model now? Maybe fourth, but third at least. Okay, great. Now, a difference here, ladies and gentlemen, is this is now treatment mediated, this recovery. Where is it going to be mediated by? Guess what? From whence is the cure going to come? From the, begins with a capital C, clinic. It's going to come from the clinic. Because this person before the day is over, will present for care at that clinic. Mark my words. They're going to flow through that clinic. They're going to secure care for that clinic. Okay? Okay. And it's to that grand finale that we are heading. Okay, but we have a few bits still to go. Ladies and gentlemen, we still need to put these people into a transmission network. Do we not? Okay, so, okay, great. Okay. Right. Okay, I think I'm going to rehearse this. Nice, okay. Ladies and gentlemen, I think I'm going to rehearse this thing from earlier today. Do you remember how we had these people, some of them start in one state, some start in another state? Do you remember how we did that? How do we do that?
Branch.
Yeah, we had a branch, remember that? Okay. So what we're going to do is to have a branch after this here, right? Boom. Just like that. Are we okay with that? And then what needs to happen? Suppose that people start either exposed or susceptible. By default, they'll start susceptible. Hence, that's the kind of dotted or dashed branch. Dashed branch. Okay? And then the others, ladies and gentlemen, will go to exposed. Okay. Here we go. Okay. Ladies and gentlemen, here we go. Here they go to exposed. Okay, now, what does the dotted branch mean? Does anyone remember?
Conditional.
It's actually default. The dotted one is default. The solid one should be conditional. So this guy here needs to be a condition. And we should really label this. We should really say like initially exposed transition. And this, ladies and gentlemen, initially susceptible transition. Are we okay with that? Ladies and gentlemen. Okay. Ladies and gentlemen. So, what do we need to do to create for this person so that they know which way to go? Anyone remember? Anyone remember? How do they know which way to go? We saw it this morning. What do they need?
Another variable.
Close to a variable, it's a parameter. And it's a parameter, it says is initially exposed. Do you remember this?
That's right.
Is initially exposed. Now, I should note that while I'm sparing you this, there's a more general way of doing this that actually takes a parameter that specifies the initial state, which state they start in. I'm tempted to do that. Do you want to see that? So a parameter that says initially which state they start in. So rather than yes or no, we can handle more cases. What do you think?
Yeah.
Okay, so all we need to do here, it's a matter of some modesty here. So all we have to do is we have to create another transition out of this, which is going to go similarly, but this one's going to go down to, instead, to this infective and symptomatic state. Here we go. Ready? Like that. And this one's going to be called initially infective transition, and this one will be also based on a condition. Okay, now this condition, this is going to change things because our parameter, instead of being true or false, what it's going to denote, ladies and gentlemen, is the initial state that they're going to be in. The initial state. Okay, now there's a couple ways we can do this. A couple ways. But I'm going to do it one way that's a little bit lighter because we have time. We have to make time. So this is going to be called initial state. And ladies and gentlemen, this initial state is going to be, it's going to be an option list, okay? Are we ready? This is going to have a certain beauty to it.
Certain beauty. Depends on the beholder.
Okay. Kurt, I will conjecture that you will see its beauty before the day is out.
I'm sure I will. I think I'm one of the beholders.
Okay, yeah, indeed. Okay, so ladies and gentlemen, we're going to add, at the cost of a little bit of mechanism, we're going to secure beauty. Okay, that's not a bad trade-off, if I might say so. Okay. Okay, this is dead. Okay. Okay. So, ladies and gentlemen, okay. So we are going to now proceed with. Okay, this is going to be uncomfortable. Let's try that. Okay, so now we're going to proceed by defining an option list, and the option list is going to actually specify the names of each of these states, the appropriate states. So it's going to go option list, and this is going to be initial infection state. Okay, and we're going to have three things: susceptible. We're going to have exposed, and we're going to have infective. Is that okay? Okay. I think there's probably a way to froth the volume. Here, let me froth it. Test. Okay, that's a little bit better. Can you hear me okay? Okay, good. No? Yeah, okay. Is that okay? Okay. Okay, so susceptible, exposed, infective in this new option list. Are we okay with that? Who needs help right now? I'm glad to come visit, do a house call. Okay? Okay, we're getting close. So we have this initial option list. It may seem cumbersome, but believe me, it's going to pay off in just a minute. So initial state, what do you think its type will be now? Will it be an integer, will it be a double, or will it be something we just added? It'll be initial infection state. Okay? Now, what will be the condition to go to exposed? Can anyone tell me? Under what condition will we go to exposed? Well, okay, sorry, under what condition will we initially go to exposed? If the what? I heard it, I think. Okay, if the parameter initial state equals what? Initial infection state dot exposed. In other words, if we're told by this parameter, hey, go to this place, we go there. Do you see what I mean?
Can you say it again?
Sure. So we just added an option list, right, that specified three possible values: susceptible, exposed, and infective, right? And then we said there's a parameter, and that parameter actually encodes to which of these options we want to be initially placed. This parameter specifies in what location we should be initially placed. This state, or this other state. Do you see that? That's why, in fact, we're encoding these. Okay, now, this initial state, therefore, tells it's gonna be one of these, right? Okay, ladies and gentlemen, and maybe by default, it will be susceptible. Initial infection state dot susceptible. It'll be the initial state susceptible. By the way, you notice why I'm calling it like this, so it doesn't get confused with this susceptible. It actually is specifically this one here. Now that's going to bring us to that susceptible, but okay, so ladies and gentlemen, this one here, initial state, it has to be one of these three values. A given person is going to have a parameter that says, you go to this state, you go to this state, you go to that state. Some are going to have a parameter for this, a value that says go to susceptible, others to exposed, yet others, ladies and gentlemen, to infective and symptomatic. Do you see that? Okay, so this parameter is going to tell them where to go. And this transition will be followed to exposed if that parameter value, the value of that parameter tells them, hey, go to exposed, then they'll go here. What will this condition be? Can anyone tell me? Can anyone riddle me that? This final condition? This one here? What will the condition be here?
Which of the states?
Equals what?
Infect.
Indeed. 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 Okay. Infective. And this one is just taken if the others are false, so we don't have to specify that. So let me go there. This one is if this is telling it go to infective, this will go to that infective state. If this one is telling it go to exposed, it will go here. Do you see the point? Do you see that? Okay. So, ladies and gentlemen, a bit of mechanism, yes, but it will be joined by even greater beauty in a minute. Okay? Are we ready? Okay. Who would like me to spend a little bit more time on this? Are we okay? Can we proceed on? Okay, now will come in the moment of beauty, of additional beauty. Already we can route them to multiple states. We're not depending on a yes, no, are you infected or not, which only really deals with two possible states. Now we're dealing with a thing we can distribute people. Now watch this. Go back to Maine. Go down Maine. And Kurt will appreciate the beauty of this moment. So we're going to Maine. Okay? Okay. Now, ladies and gentlemen, we need to, remember in the population, we're going to need to specify someone's initial state, right? For each, remember, population, for each person in the population, in turn, we need to specify the parameters for that person. Remember that? Right? For the population of people, for each successive person, we need a rule to get the home for that person. Right? This is to draw it randomly from the set of homes. We need a way of getting the initial state for each successive person. What state is this one in? How about this one? How about that one? So, what state am I in? What state am I in? What state am I in? Right? We need a way of a rule to specify for the initial state, a formula that for each person in turn will be run to assign them to an initial state, right? We need a way of drawing that from a distribution. What initial state do it? How can we draw something from a custom distribution in any logic? It harks back to almost the first example we created with heterogeneity. How can we do it?
In the agent palette.
Indeed, in the agent palette, what lies before us? Custom distribution. Let's draw it in. And this will be called, now, initial state distribution. Okay? Watch that. Now, Kurt is yet innocent of this. So it's going to be an initial state distribution. Okay? Now, Kurt, watch this.
Watch it.
Because initial state is encoded as an option list, what can we make this initial custom distribution be? It's a custom distribution that's continuous, discrete, or options. Indeed. In which option list? Initial state. So now, ladies and gentlemen, now we can specify the fraction of the population that's to fall in each of these groups. So perhaps we want,
It doesn't even have to be a fraction. It can be just an absolute number, right?
it could be an absolute number, yeah. That's exactly right, yeah. It could be, 300 of them, or in this, 1,200 from the empirical evidence.
Yeah.
Now, I'm gonna make it maybe 5% are susceptible. Maybe 3% are susceptible, 2% are initially exposed, and the balance 95% are initial. Oh gosh, sorry. Sorry. Sorry, the day is late. Okay, this is what we want. 95% susceptible, 2% exposed, 3% infective. Are we okay with that? Are we okay? Okay. Now, what do we have to do to complete the crowning achievement? What do we need to put here for the initial state for the population? How is it? What's the formula it's going to use for each successive person to determine their initial state? Can anyone give me that formula? Sorry?
Distribution.
Yeah, the initial state distribution. What do I need to do to it? I need to call it. Give me a value. And it's going to draw from that distribution. That, ladies and gentlemen, is in my mind beautiful. We can elegantly specify in a declarative fashion, in a distribution, this fraction of the population is in this initial state, this one is in that one, that one, that one, however many initial states we have. And then we can divvy them up between those states in a very clean fashion. All we have to do is draw from the distribution. So for each successive person in the distribution, we will figure out their home by drawing from the homes. We'll figure out their initial state by drawing from this distribution. Oh, if they're susceptible. Okay, the next person. We'll draw a home for them. We'll draw from the state distribution. Oh, they're infected. Next person. We'll draw from the homes, draw from the initial state, and they're susceptible, etc. For each successive person, these will be run. Does that make sense? And that will permit us, ladies and gentlemen, to fill in, just as this morning we filled in that Boolean. What this means is each person will start with some initial state, as has been picked from that distribution. Some initial state here, picked from that distribution, right? And then because of that, they will be routed hither and yon. Okay, to this or to this or to that. Okay, are we okay with that? Okay, ladies and gentlemen.
Nate,
Yes.
do you put two equal things when it's Boolean?
Okay, very good question. I'm grateful for that question. We put two equals when we're testing equality. Suppose we did this. Don't do this, either at home or here. But watch this. Suppose I did this. What would the implication be? Can anyone tell me? First of all, it would complain, because it would say that's not going to give true or false. But what would it try to do?
Put everyone there.
It will assign to initial state an actual value. It will assign that value. Now, fortunately, Java as a language has been crafted to make it so it will realize that and refuse to do it in this position. It will realize you want to test equality, but this is the way to test if they're equal, rather than overwrite it. In this case, it looks like it's trying to overwrite it. It's trying to set initial state to a value. Is that okay?
Yeah.
Okay. Ladies and gentlemen, so we have this distribution now. Okay. Let's run this model for just a moment, but there's still one piece missing, to wit, the distribution network. Okay, it's an unhappy camper. Let's fix the unhappiness. Oh, look at that. It says main. Oh, I typed it as capitals. Okay. Java is case sensitive. It is a strict taskmaster. Okay. And here we go. Here we go. Some people are starting infected, some people are starting exposed. Okay? Okay. Now there's some pieces to fix up, but fortunately these pieces I believe will go quickly now, even though they're key pieces. So the first is, ladies and gentlemen, we need to implement a network in which people can be connected. Okay. Okay. Now, this next piece will have a measure of delicacy as well. Okay. So I'd ask you to follow this carefully. Go to main. Go down main. In main, select it so it can be viewed in the properties window. Make sure main is viewed. If necessary, you can select it over here. And then you will go down main, down in the properties window. Okay? And within main, ladies and gentlemen, you will go to this area called Space and Networks. Okay? Are we okay with that? Ladies and gentlemen, we are going to want to connect two people together if they lie within a certain distance of each other. We're assuming a distance-mediated infection. Ladies and gentlemen, this is going to be a distance-based connection of 75. Okay? Connection range 75. Ladies and gentlemen, we want that to apply for people, not for clinics and homes. The clinics and homes are not in a network. Therefore, we will do the following. We will uncheck homes and clinics here. We will say, don't bother putting homes and clinics in this network of connection, this set of networks. Rather, just put, only population, not clinics and homes. Is that okay? Okay. Only homes and clinics are not selected. Population is selected. Are we okay with that? Population is selected, homes and clinics are not. Okay, ladies and gentlemen, let us now run the model, and I would predict we probably won't see anything yet in terms of a network. And I'd like you to tell me why. What have we forgotten to do?
Make the network viewable.
Make the network viewable. That's the key thing. And whither do we go to make the network viewable? Sorry? Yes, connections of whom? Whose connections?
Patients.
Main's? No, the patient's connections, not Main's connections. Main's connections are kind of underutilized. They're almost vestigial connections. Okay, we tend not to really use them. Connections here in patient are where the action's at. We want to go down to animation, and we want to draw a line connecting agents and draw the line behind agents. Okay? So in connections, the key thing is for patient, this is all in patient because we want the patient's interconnections to be drawn. You want to go to patient, you want to scroll down, you want to go to animation, if necessary expand it, and you want to check draw a line connecting agents. Are we okay with that? Let us now simulate it. Here we go. There we go. Who is connected together? Who is connected to whom? It is patients, ladies and gentlemen, connected to each other. It is through that network, ladies and gentlemen, no less, that the infection will spread. Right? Okay, so let us simulate it now. Let us simulate the spread of infection. Okay, so we're going to speed up here, and we're going to see if infection is spreading. Okay, I don't actually see grand evidence that infection is spreading. Do you see any evidence? I would have expected to see, spread out from these initially infected, but I don't see that. So ladies and gentlemen, let's go figure out what's going on. Okay?
Or I think you have the message exposed
Oh.
being sent from exposed to the internal thing, you have the exposed message.
This-
Should it be like sending them to infected?
You know what this is? Thank you. What does this depend on? This depends on messages.exposed. It's checking, did I receive the messages.exposed? And it's a beautiful thing that was just pointed out, because this is inconsistent with that. What message should I be sending here? What message? Is it this one? No, I should be sending what? Messages.exposed. Thank you very much. That's great. A key thing. Messages.exposed. Okay? Messages.exposed. Okay. So that's one thing that's wrong. But I would argue there may also be something with contact rate. I don't know that we set contact rate to a value. I think the contact rate is currently unspecified. Let's set the contact rate, ladies and gentlemen, to be a default of 1 per day. That's in Maine. So in short, we fixed two things. To wit, this transition here, we changed it to send the messages.exposed. Secondly, we went over to Maine and we set the contact rate to be 1 per day. Notice, by the way, is this double? Is that the best we can do?
Right.
It should be a rate. You folks are really good, seriously. I really am impressed. Okay, so we'll specify a per day rate here of 1 per day. Okay, 1 per day. And now inpatient, this is also on a per day basis, so I think we're fine. I'm not positive that whether it would translate automatically. I think it does, but I'm not sure actually. Not sure. There was something I saw once that made me question that. But here we have it specified on a per day rate of 1. Are we ready to try again? Okay. Ladies and gentlemen, let's try this. Here we go. Okay. Okay. I see some action occurring. The telltale signs. Okay. So why is everyone infected now? Why do they remain infected? Because cure from that is what? Mediated by what? Riddle me that.
Going to the clinic.
Going to the clinic. And right now they're not presenting for care in the clinic. Okay? So it's time for me to stop this recording and we're going to proceed on to the final summit. Okay? The crown jewel of this will now be revealed. Okay.